We've got some Halloween background thunder here as well. I don't know if you can hear it.
We do. We have it actually where I am too. There was lightning not too long ago. It's very mood appropriate.
It is. Welcome, Austin, Gershom, Swanello, Vanita.
Welcome, everyone. I'll put you on this side. Okay. All right. So everyone, while we wait for you, if you could go to www.kahoot.it and then type the code in. We're going to start with a game today. And so you'll see your name pop up on the screen when you're in. Aha, welcome Gershom on the board.
This is serious music, eh?
Yeah, they go the extra mile.
Wow.
Yeah, it's a bit of a brain worm though. It does get into your head. In the end, you start bobbing around to it. It's a little bit like. But,
tonight when we go to bed, we're gonna start singing this.
Okay, who else? Solelo, are you gonna join us? Vanita? Don't be afraid, I promise. Sonia.
Welcome to all those who's just joining. If you haven't heard, you can just go onto Kahoot and then enter the spin, and then we will see your name pop up on the screen so that you can start this awesome, is it a quiz with Peter?
It's a quiz, yeah. It's slightly different to the last one.
Okay. If you have any questions or if you guys get stuck, just ask us. Unmute yourself and ask what to do.
Yes, please do, yeah. I know this is new, so basically you go to www, it should be on the screen, .kahoot.it. You can either go on your cell phone or you can go on an extra tab on your window if you're on a computer, and you type the code in. In fact, I can even model this for you. If I type it here, www.kahoot.it. Yeah, .it. If I click that, then I have to enter the game code. And that's what I should get. Are there any issues or problems with that? Let's have a look. Lutando, how's it going with you? Are you able to get on? Some care law? Okay, welcome everyone. I know today's starting off a little bit differently. We're just trying something different with this Kahoot at the beginning as a little warm up for the day to give us some energy to get going. Oh, Wanika, welcome. Oh, nice people. Yes, welcome everyone. Lutando's there. Fantastic.
Very cool.
Ah. So in about a minute or so, we're going to start the game. Even if you come late, but you can still join us. It's not a case of it kicking you off. You just need, Alzan, if you could just type the www.kahoot.it in the chat, and then the code as well. And so then anyone who comes on late can just join us while we're doing this. Okay.
Awesome, done.
Okay, fantastic. Okay, get ready, everyone. So this is just going to be you need a pen and a piece of paper standing by. And obviously, we're carrying on from the last lesson. And it's just going to give us a chance to reflect on what we know and what we don't know at this stage. And if you're coming in late now, just look at the chat stream. You will see that there is the address and the code there. Okay, but I'm going to press start, and then we're going to go. Let the games begin. You need to vote on your so can everybody see the
yes, we can see the whole screen.
Fantastic.
So Peter, I think there's one or two learners that might struggle to log in. For those who are struggling, should they just put their answer in the chat?
Yes, that's exactly right. So we'll go with A, B, C, D, and we'll go A on top, B below. Then look, A is red, yellow is B, blue is C, green is D, and we'll go with that. That's perfect, actually. Okay, so the right answer would have been B or the yellow color. Okay, so we'll have a look at that now. Okay, well done to Gershon. And to the students in the chat, will you just give them a shout out, Alzan, if they get that right there too?
I will for sure.
Okay, what do we think? Find the length of the missing side, which is over here. Okay, I'm going to give you another 10 seconds for this one. You're going to have to commit. And then I'm going to...
Okay, guys, so if you have the answer, just say A, B, C, or D. Put it on the chat. Otherwise, if you are on the quiz, then you just, put your answers in there.
The right answer there would have been A, and there's 5 students got that correct. Well done, everyone.
Awesome. 2 on the chat has it right as well.
Fantastic.
Good try, Bulunko. Good try.
Okay, next one. You're going to need a pen and pencil probably for this next one. It's a little bit harder using this idea of the theorem of Pythagoras. Wait for the music to drop as well. Dun, 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 dun. Okay, so again, remember, red is... Okay, answer was indeed that one there. Well done to everyone. Second last one. Find the length of the missing side. Okay, so red would be A, yellow would be B, blue would be C, green would be D. Okay, I'm going to give you 10 more seconds and we're going to move on. Three, lock in your answers. 2, 1. Okay. Not bad, not bad. Okay, last question. And Lenuko is shooting up out of nowhere. Gershom is still at the top though. And Wanaka is on fire, it says. Okay, a little bit more tricky. What is this length over here going to be?
So guys, for those who's not part of the quiz, feel free to put your answer in the chat. We'd love to see it, to see whether you got it right with the other learners, okay?
Absolutely. So again, A is red, B is yellow, C is blue, and D is green. So that's the code system you can use to answer on the chat.
Hi. Hey.
Hey,
Hello.
Tando.
How are you?
Good, and you?
I'm also fine. Can I please ask, what are we doing here actually?
So we're just doing
It's
the
my first
quiz.
time. We're just
Cool. Okay, we're going to start the lesson properly now. This is just the warm-up. So,
okay.
just to end the game, we're just going to declare the winners. And the winners are, in third place is Lotando, in second place is Gershom, and in first place is Wanaka. Well done, everyone. And so I'm just going to bring this initial starting thing to a close. I just want to point out, in fact, I'm going to start the lesson properly for today. So that was just a little recap of the last lesson. And the main focus of the last lesson was a theorem called the Theorem of Pythagoras, which I'm going to talk about now. And just give me a thumbs up if you enjoyed that, and give us a thumbs down if you didn't enjoy it and you think it was not a good use of your time. So just give us a little vote there, and then we'll go from there to start the lesson like we normally do.
Tando, do you have a question? Or is that just a thumbs up?
What?
So I was saying Lutando.
Okay.
I can't hear you.
Okay, shot. Thanks, Lutando.
Cool. All right, let's get started. So hello, everyone. I've
How
met
do I
many-
show my video? I can't see people. How do I do it?
Okay. Can everybody see me okay? Ozan, can you see me?
Yes, we can see you.
Fantastic. So just to welcome everyone, I know that a lot of you I've taught before in a previous unit. Could I ask for those who are listening to put yourself onto mute just for this moment, and then you can turn yourself off mute when we ask for questions in the lesson. That would be fantastic. Okay, so my name's Peter, and I'm your teacher for this unit. Coco filled in for the previous lesson, and so thank you to her, and it looked like you had a lot of fun. And just, yeah, I'm very happy to be with you here today, and we're going to have some fun doing some geometry. So just some basic rules. When we're trying to communicate, Alzan is always online in the background if you have a problem. And so you can type in the chat and she will answer you. And you can turn your mic on to ask a question at any time. But generally, if I'm talking, you want to leave your mic on mute. Okay. You're welcome to turn your webcam on. In fact, it's fantastic to see you all. You're not being recorded in any way. But I can see you, and it's super helpful for me as the teacher. And so that's just some basic rules for the road. Okay, so just before we really get going, a lot of this section deals with triangles. And so we have to make sure that the vocabulary we use, we cover at the very beginning. So I just want to quickly talk about vocabulary. So what do we call the things that I have put red little dots in? And if you could either put it in the chat or jump on now and give me an answer. What is the word we use for these things that I've colored red? Austin, have you got any idea?
we've got a message from Oratila saying it's angles.
They're angles. So these, you're right, like this over here would be an angle, or this over here would be an angle, or even that would be an angle. The special name for the well, sometimes we call it corners, but it's also given the word vertices. So, but at each vertex, there is an angle. So that is an important word. So I'll put that there, angle. And each triangle is going to have 3 angles. So that's some important words. We also talk about the sides of a triangle. It's kind of obvious, but you know, it's important. And each triangle has 3 sides. And often we will mark the sides. If we're going to try and show that they're of a different length, we use this notation like 1 strike there, 2 strikes here, 3 strikes here. And we use a similar thing for angles. And all that does is it tells you that the one is different to the other. Okay, so when I use this notation, I want you to be aware of what I'm doing. And normally what we'll do, not always, but in a triangle, we talk about the smallest and the biggest and the middle side. And so often, I haven't drawn a perfect scale here, but the one with 3 stripes would be the longest side. And then the one with 1 stripe would be the shortest. And then the one in between would be the middle side. So that's just some language. Something else that you'll see that we do with triangles is that we give the vertices capital letter names. So we may talk about the vertex A, B, and C, or we would then call it, you can also call it angle A, angle B, and angle C. But what we do to make life a bit easier is sometimes we call the side opposite the capital A, lowercase a. We could also call the side BC, but a lot of the time we use the lowercase letter opposite the angle. And we would then call this side over here C and this side over here B. Now, that is just some sort of basic language that we use in mathematics. However, it's not wrong to say that the little a is the same as the length BC. That's also correct, but a lot of the time you'll see me use lowercase letters for the sides and big capital letters for the angles. Give me a thumbs up if you've heard that before. Give me a thumbs down if you've never heard that before. Just so I know what's new and what's different. So thumbs up is you've heard it before. Thumbs down is you've never heard this idea before. Okay, so I see a couple of thumbs up. Anything else? Okay, so this is just part of your general knowledge of how to do geometry. Now, something else that I want to point out before I really get to the Pythagoras part is there's 3 main types of triangles. In fact, I'd love for you to put this in the chat or jump on. So let me actually go to people. Oratile, could you give me one type of triangle that you know exists? And you can either type it or jump on.
A right-angled triangle.
Right-angled triangle. That is fantastic. And a right-angled triangle looks something like that. Tosley, could you give me another triangle that you know about? Tosley? Or Leniko, could you also give us a different type of triangle?
A scalene, sir. Scalene triangle.
Fantastic. Okay. A scalene is where all the sides are of a different length. So to indicate they're all of a different length, I'm going to make these awesome markings, and that is going to be my scalene triangle, and this was my right triangle. What other types of triangles are there in the triangle families of the world? Gershom, I know
Isosceles.
Oh, isosceles. Who was that?
Oratile.
Oratile. Thank you very much. Isosceles, what does isosceles mean? It sounds a bit like ice sausages. Give me a little description.
So only two sides of the triangle are equal, and then the other one is not equal to the other two.
Perfect. So two of the sides are equal, or what's also true is that two of the angles are equal. And so that's an isosceles triangle. What other types of triangles are there that you sometimes hear spoken about in maths class, but we haven't mentioned yet?
So can I answer?
Yeah, please do. Who's speaking?
Bandile.
Bandile, please jump in, Bandile.
Straight line. No. Never mind. So never mind.
You're on the right track. Anybody want to jump in? Say it again.
Equilateral triangle.
Ah, I like it. I like it. An equilateral triangle has all sides and all angles equal. Okay. And what do all of those angles have to be for bonus points? Anybody know what the angles have to be in an equilateral?
They have to be equal.
They have to be
equal.
60 degrees.
But all triangles add up to 180.
60 degrees.
60
degrees each.
Fantastic. Okay, we're almost there. So we've done isosceles, scalene, equilateral. What about, have you guys heard of acute angle triangles? What does that mean?
It has three angles that add up to 90 degrees.
Okay, almost. All the angles are less than 90.
Or
So
less than 90.
less than 90. So that's an acute angle triangle. And then the last one is an obtuse angle triangle. And that's one
Which
where
has-
it looks like it's bending over, where one of the angles is greater than 90. So that would be this angle over here. And we call this an obtuse angle triangle. Now, you can actually have combinations of these, but it's important that we at least mention the vocabulary right angle triangle, scalene triangle, isosceles, equilateral, acute, and obtuse angle triangle. And I will refer to that throughout today. Are there any questions or comments before I move on? Is there any other vocabulary you've heard in class that you want to clarify? Okay. Then I'm going to move on because I have an awesome GIF or GIF, depending on how you say it for you. And I want you to just have a look at this awesomeness while my computer refreshes. Okay. Now, I want someone who hasn't answered yes, like, who hasn't answered yes? Asonge or Bandile or Arson, what do you think the picture is trying to show you? Jump on the line and give me your best verbal description. Yeah.
This is trying to show us that the sides are not equal.
Sides are not equal, absolutely, because there's different size squares on the sides. Anybody else? What's in the triangle? So when you turn it over, it's almost like the two little squares fill up the big square. Can you see that? So this is a rather interesting relationship. I'll show you another one below that I prepared.
I think.
Yeah, go for it.
So, we were learning about the theorem of Pythagoras. So, in the picture, in the theorem of Pythagoras, you know that h squared, which is the big circle.
Yes, the square, yeah.
And then we say b squared plus c squared equal to the big circle. That's why the smaller circles equal the amounts in the big circle.
Yes. Okay. So this is the very important theorem of Pythagoras. So honestly, guys, the ancient Egyptians knew about this back in the day. And it was part of the reason why they could make things stand up straight, because they knew if they had particular Pythagorean triples, they knew that they would form right angles. Now, the picture does look pretty, but it maybe doesn't explain everything to you. So I'm going to draw a triangle like based on this. So let me go, I'll draw it like this. If we have a right angle triangle, there's a couple of important names that we need to talk about. And the one is the length of the side, the longest side, called the hypotenuse. And you spoke about this a little bit in the last lesson, but the hypotenuse is always the side opposite the right angle. If I can draw over this, I can draw over it, fantastic, sort of. It's going to be the biggest square here. It's going to be this square and this area over here. Now, what Pythagoras' theorem says is if you build a square on the longest side of a right angle triangle, it will be equal to the sum of the two squares on the other two shorter sides. So that's what Pythagoras' theorem says. Now, in this particular drawing, they are saying c squared equals a squared plus b squared because c is the length of the hypotenuse. But sometimes sometimes when teachers are referring to it, they also call the hypotenuse h. So I suppose we could also, if we called it h, we could say that h squared equals a squared plus b squared. And this is the magic relationship of the theorem of Pythagoras. Once people realized this, they could use this fact, and once they proved it, they could use it to solve all sorts of calculations involving triangles. And if you're building buildings and things like that, you really want to make sure that you have right angles to make sure your buildings are standing up straight. And so one of the most famous Pythagorean triangles is what's called the 3-4-5 triangle. And the 3-4-5 triangle, if you take 5 and you square it, what do we get?
25.
We get 25. Okay, so 25 is going to be the area of this big square here. So I'll draw it in for you. Now, if I want to think about this one over here, what is 3 squared?
9.
9. And what is 4 squared?
12.
16.
16, okay? So what the theorem of Pythagoras says is in a right angle triangle, if you get the square of the longest side and you square the other side and you add it to the square of the next one, they will be equal to each other. And this is true. In the 3-4-5 triangle, we see 9 plus it just shows you, can you see how the big one is full and then it gets turned over and it goes from there. Okay, let me move on and let's actually use this in a question. Okay, the other stuff is a little bit magic. Preview. Okay, task number 1. So let's do one together and then you're going to do one by yourself. So if I look at question A, of these 3 sides of the triangle, the longest side is this one over here. And I do not know what this is. This is a mystery to me. I do know it's a right angle triangle because there's this right angle symbol. But if I didn't know about this theorem of Pythagoras, I would not know how to get this. But because I know about this relationship, and I will go in a bit more detail maybe into the proof in another lesson, but for now, I'm going to focus on using this. I'm going to say this. I'm going to say a squared is equal to 16 squared plus 12 squared. And then what I'm going to do is, because I'm making a mathematical argument, I'm going to write the reason Pythag with a dot. And this is acknowledging the fact that I'm using this idea to help me. Now, that doesn't actually let me find the a value yet, but I've created what's called an equation, an equivalence. And once I've got the equation, what I'm going to now do is use my knowledge of equations to solve this. So a squared can say the same. 16 squared, I can use my calculator if I like. I think it's 216, but I'm a bit rusty, so let's see. 16 times 16. Oh, it's 256.
256.
Okay. And 12 squared is 100 and 44. And so we get a squared is, I think this is going to be 400.
Yes.
Okay, now here's the problem. We've got a squared is 200, but we didn't want a squared. We wanted a. And so we use the golden rule of equations. And what the golden rule says is, as long as we do the same thing to both sides, they stay equal. Often teachers use the analogy of a scale. Like if you have a certain amount on the scale to start with, and you take away something from both sides, the same amount from both sides, you're still in balance. Or if you add the same amount to both sides, you're still in balance. And so as long as what we really want to do is find an operation that gets rid of the a squared, which undoes a squared. Does anybody know what that operation is called?
Square root.
Square root.
Perfect, guys.
Square
You are
root.
doing it tonight. So we square root it. Now, if we square root a squared, we get a. And if we square root 400, we get 20.
20.
And the answer is 20. And then we are very, very happy with ourselves. Okay. Now, what I would like you to do is I'd like you to do B by yourself. And then I even want you to try C. And C is a little bit different. And see if you can use the same logic that I used here. Okay. So guys, I'm going to give you about 3 to 4 minutes. And then what you're going to do is you're going to type your answer in the chat, or you'll jump on and you'll give us your answer. And then I will work through the answer with the full working out. Okay. Over to you. Okay. I'm going to get some water. If you are confused, just type in the chat. I can see the chat if I look across on my other screen. And I also want you to try and do the working out that goes with this question. And if you feel like you're just on top of this, then you're also free to try out and do question D while we wait. But most of us are going to be working on B, C, and D. While I'm trying to rub this stuff out.
Hi.
Hello.
Hi.
Hey. What is...
Can you hear me? I have a network problem.
Okay, go for it. What's your problem?
Can you guys see me?
Can I see you? I can't see you at the moment, but I can hear you loud.
I'm asking.
What is your question?
You can... Sir?
I can see you. I can see you.
Oh, okay. Okay, I'm back.
What's your question?
Now I was asking if you can hear me because I have a network problem.
Okay. I can hear you very loud and clear. Awesome.
That's what I've been saying.
Okay. So I'm going to do B. And so for those of you who are happy with B, you can carry on working on C, but I'm going to do B. And the first step is to identify what is the side opposite the right angle. And opposite the right angle is 10. And so I'm going to say 10 squared is equal to B squared plus 6 squared by Pythagoras. Now notice how it's slightly different to last time. Slightly, but only slightly. Now, I first need to get a value for 10 squared. So I'm going to get 100. And now I'm going to get a value for 6 squared, which is 36. But my big problem is I want to know what this is. And so this thing over here is getting in my way. Has anybody got a suggestion about what I need to do? You can jump online, chop if you like. What rule for equations? What would be so nice? I'd love it if this 36 could go away. What should I do? So, I heard somebody. Gershom, do you want to jump in, or Keke? What do I need to do? So I really like this 36 to go away, but if I do that, I need to make sure that I take it away from this side at the same time. So 36 subtract 36 is nothing. 100 minus 36 is going to be 64. And so now I'm left with this idea that 64 is b squared, but now I would really like b. And so to get b, I'm going to square root both of these sides. And the square root of 64 is 8. And so b is 8. And I see in the answers there, I think I saw some 8s popping up there. I did indeed. Well done to Gershom. I see that. Asonge, I see that. Fantastic. Let's have a look at C now. So if we look at C, let's make sure we find the hypotenuse. The hypotenuse is 13. So we go 13 squared equals 12 squared plus C squared. And I must write the reason. Now I can use my calculator, and because I've memorized my timetables, which I highly recommend everyone, I know that that's 169 and this is 144, and that's that. Now you obviously can use your calculator. What am I going to do about this 144 that's getting in the way? Here for an answer. Go for it.
You're going to say 169 minus 144.
Perfect. And I'm going to have to do it on both sides so I don't break the rule of balancing the equation. And so I'm left with just a c squared on this side. And what have I got on this side? I think I've got 25. And the wonderful thing about Pythagoras is this last step pretty much always stays the same because you always have something squared. And so my answer is going to be C is 5. And I should actually say, you know what, guys, I've been a bit naughty here. I should have said centimeters because the units are given in centimeters. So it's always, if you're given units, use the units that are given. Okay, so that one was centimeters. Okay, and D, do you need a bit more time? So hands up if you need more time, hands down if you don't need more time. Let's just see the thumbs flying. Should I? Hands up, you need more time? Okay, perfect. Okay. I'm going to give you a bit more time to do D and see what you can get, and then we'll give you some feedback. Well done, guys. I can see that you are getting this under your belt. Alzana, any comments, questions, anything from you? Important? Is everything looking good on?
No, nothing on this side.
Awesome.
Oh yeah, I have a problem with
Yeah.
simplify when you have to simplify, like when you have to solve x.
Which question are you on?
Like solving x.
Solving for x. Okay.
Yes.
So should we look at it in when I do question D now? Do you want to show me where you're getting stuck in question D, and then we can do it together?
Question D.
Okay.
So if you look at the question D that's on the board now, okay. So if you look at the one that's circled, we have to find what that value of D is, and that value of D is a side in the triangle. So it's this side here. It's what we call the hypotenuse, or the longest side. Now, do you know how to write out this step where we go D squared is 8 squared plus 15 squared? Are you okay with that?
Okay, D squared is, should I solve the sum?
Yes, you start by, this is called the relationship of Pythagoras. And so this is the first step where you write down the relationship where the biggest side squared is equal to the sum of the other two sides squared. And we call this the theorem of Pythagoras. Now, we haven't solved it yet, but this is step 1. Now, step 2 is to get a value for 8 squared and 15 squared. And you may need to use your calculator here. So you would get 8 squared should be 64 and 15 squared. Can you give me an answer for that? What's 15 squared?
15 squared will be 15 times. Okay.
In my memory, it feels like it's low 220 something.
15 squared is going to be 225.
Perfect. Okay, now, what's 64 plus 225?
64
plus 225.
225 is going to be 289.
Perfect. Okay, we're almost there. Now, the final step is to realize we are not looking for d squared, we're looking for d. So we need a way of undoing what squaring does. And the way we undo squaring something is by using an operation called a square root. And so we're going to square root this side and we square root that side. And what that does is d squared becomes d. And now I need to find what the square root of 289 is. Now, your calculator should be able to give that to you. I'm guessing it's bigger than 15. So
17.
17. Perfect. And that's it. So whenever you see a right angled triangle in future, whenever you have 2 sides, you can always work out the third side using this relationship. And that's really what the theorem of Pythagoras is. Okay. Let us move on to a more sort of like where you're going to have to use your calculator. So I want everybody to try and find for me this length EF. So I've given you a triangle with 2 sides, and I want you to work out what EF is, but you're going to have to use your calculator because it says to 1 decimal place. Okay, let's get the show on the road. So remember, what's step 1? Who wants to give me step 1?
I'm lost.
Okay. So step 1, I'll even put here, step 1. We have to find the longest side. So which is the longest side that's opposite the right angle in this particular question? Is it this side?
8.9 centimeters.
Yep, it's this one over here. Because
Hypotenuse.
it's opposite this. So when we write this out, we're going to write 8.9, and I'm going to put a bracket here to say squared. But now what I need to do is I need to take the other 2 sides and incorporate them into this relationship. So what Pythagoras says is take the other side, 7.9, and square it. But now I've got a little bit more trickiness here because I could call this d, a little d, because it's opposite the big D, or I can call it EF. I don't really mind. Both of them are correct. I think I'll call it EF for now just to make it a bit easier. But essentially, that's what the theorem of Pythagoras says. The only difference, and I'll put the reason, I must put the reason. The only difference is that I've now got decimals. Now, squaring 8.9 is actually quite hard in your brain. Well, it's not that hard, but it's probably preferable to use your calculator. So can somebody give me what 8.9 squared is? I'm guessing it's just below 81 because 9 times 9 is 81.
79.21.
79.21. Okay, so that makes sense. Now, what is 7.9 squared?
62.41.
62.41. Fantastic. And the EF squared has to just stay like it is. Now, the problem for me now is this 62.41 is getting in the way. I'd really like the EF to be by itself, or the word mathematically we say is like isolate the variable. So who's going to tell me what do I need to do to this equation to move this over? What is the step that I have to carry out? And you can just shout it out or jump on, or it's probably quicker to just shout it out.
Okay.
Subtract from both sides.
Perfect.
Subtract 60.41.
Yeah, so both of these sides, and I'm running out of space, but basically minus 62.41 minus 62.41. And could somebody tell me what the answer is? What's 79.21 minus 62.41?
79.
No, it's not, can't be that. It's going to be about sort of 17.
17. 17.
Yep. 17.
It's giving me 84.
16,8.
16,8. Perfect. Okay. We're almost there, guys. Hang in there. We're almost there, because this is a bit harder. Hey, this is decimals and it's messy. So, and I'm kind of, you see I'm coloring it like a Christmas tree here, green and red. Okay. Now, last step, EF squared. I don't want EF squared. I want EF. And so what I'm going to do is I'm going to do the same step I've done throughout this, and I'm going to square root both sides. And if I square root this side, I get EF by itself, which is what I want. And now I need you to tell me what the square root of 16.8 is. And again, common sense tells me it's going to be a little bit above 4, because the square root of 16 is 4. So if I've got a little bit more than that, I'm guessing it's between 4 and 5. So what is the answer based on?
4,6. 4,6, I think.
4,6.
Is it?
4.1. I got 4.1.
Yeah, so that seems a bit more. 16.8, I'll do it here with you. So square root 16.8. I get 4 point, yeah. I actually get 4.09, but we have to round off to only one decimal place. And so when we round off to one decimal place, it's going to be 4.1. Yeah. And again, this should be 4.1 centimeters. Okay. Well done, guys. Like, that was quite a bit harder. And you had to do, if we have to look back here, let's look at the steps. So step 1 was identifying the longest side. Step 2 was writing out the relationship. Step 3 was moving things around. Step 4 was square rooting. And then after that, we had our answer. So there's about 4 steps in this process. Okay, let's. I know.
I'm lost. Okay.
Okay, hang in there. Okay, now, this is a swimming pool. Now, I'm not a good artist, but I'm going to try and draw you a swimming pool. Okay, so pretend it's a hot day, and you're going down to the swimming pool. Maybe you got one in your house, or maybe you got one at your school, or maybe, I don't know. And it's a rectangular swimming pool, and it's 21 meters wide, 21 meters wide, and 50 meters long. Now, what do we know about rectangles and their angles? Does anybody know anything about rectangles? What might be important here?
All the angles equals to 90 degrees.
So important. So important. Yes. Now, it asks us in this question, calculate the length of the diagonal. Now, the diagonal is going to be the line that goes from this side to this side. And so what we now have is we have a right-angled triangle where the main right angle that I'm worried about is here. And the hypotenuse, or the longest side, the side opposite the right angle, is here. Work out for me what the diagonal is of the swimming pool, please. And I want you to do all the steps you need to, write it out properly, and then I'll come along and offer corrections in a moment. Okay, so what's step one? What do we always have to do? Think about that. So you may be wondering, what do I call this thing over here? Now, if you want, you can call it H, or you could call it D for diagonal. It won't make a difference. I'll call it H. But so H squared is equal to 21 squared plus 50 squared. And I've left something out. What have I forgotten? What happens if my teacher doesn't know? How do I know this? What's the key thing I have to comment on?
Theorem of Pythagoras.
Yeah.
The reason.
Totally, guys. Pythag. Okay. Because otherwise, if you don't know, it's almost like you've sucked it out your thumb. You know, there has to be a reason why these squares are suddenly all equal to each other. Now, the next step is probably going to involve some calculator work. So could somebody give me the answer? What is 21 squared plus 50 squared?
441.
It feels a bit small to me. It feels like if you square 50, that must be about 2,500 or so.
2,941.
Is that what you, okay. 2,941. Okay. Now it's a little bit easier in this case. And now the problem is I need to get H by itself. And I do the same step as before. And I square root both sides. And what answer am I going to get for that?
54.2.
4.2.
Awesome. That looks about right to me. Let me just check it though, just in case. 2941, 54.2, and you've rounded off correctly as well, because it's 54.23, which means you must round down. Okay. Let's try and squeeze in. Oh, okay, we're running out of time. Let's leave that for next time, for the do now. Let us finish with I have one more fun quiz. So this is a different tool quiz. And I'd love for you to try it, just so I get a sense of, so you can tell me what you like and what you don't like. So I wonder, let me open this up for a second. Let us do this. Classic, continue. Okay, guys, you've been fantastic today. We're going to end with this quiz, and then we're going to say our goodbyes. But I really, really want you to do this properly, because it kind of shows me how much you've learned from today. So if you go to joinmyquiz.com and you type in the code 576713. Now, Ozan, could I ask you to just put this code in the chat as well? Because once we start, some students may take a little bit of time to join, and some students may even continue on past a certain time. But I'd like us to try and do this now. And yeah. Okay, welcome. So we're going to take 5 minutes to do this, and then we're going to squeeze in the 2 minutes before someone turns off the lights for both of us. So guys, I'm going to start you off now. You can carry on joining throughout, and I will leave the questions on the board, and just do the best that you can. So if you can't get onto the app, you can do it by looking, and you just go options A, B, C, or D from the top. So for example, question 1, what kind of triangle does Pythagoras theorem work with? It works with right triangles. So I'd say 1A. Okay. So even if you can't get onto the app, you can do it by just looking at the board here. Alzan, is the music a bit loud or are you surviving?
No, we're surviving on this side.
So for the second one, what is the formula used to solve for the hypotenuse? So if we look here, a squared plus b squared equals c squared. Looks to me like that would be the right one because that's the theorem of Pythagoras. Question 3, identify the hypotenuse. Which of these 3 symbols is the hypotenuse in this case? I think it would be the Z because it's opposite the right angle. I'll just leave these up for a little bit of time. The music is making me dance. It's kind of groovy. Dun, 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 dun. Okay, so question 4's answer I think is going to be 5. Let's scroll down a little bit more. So, Alzan, I'm going to come back to you in a moment. Even for the students who haven't finished, I know we just want to say goodbye before the lights go out. So stand by. Okay, guys, I'm so sorry. We're not going to quite have time to finish. Don't stop your game. You can carry on after we finish, but Alzan is just going to say congratulations and sort of end the session. But the games can continue in the background. I'm not going to close the game, okay? But I am going to turn my sound down so that everybody is... And over to you, Alzan. Thanks so much.
Awesome. Thank you, Peter. That was great. So guys, well done for your hard work today. You finished your second lesson on the intro of Pythagoras Theorem. And next up, we will have applying the Pythagorean Theorem. I hope I'm saying that right, Peter. And then I'm just quickly gonna go to the lessons that you guys need to do before the next one. So you go into your Watobe app. This is before Tuesday, before our next class. Make sure that you go into Theorem of Pythagoras in your topic. As you click in this one, then you will find under Theorem of Pythagoras, there's these two lessons that you guys can do. The first one is use Pythagoras to find side lengths. And the second one is use Pythagoras in, I'm not going to try and say that word. Peter, I don't know if you want to stand in there. But the second one, this is what you also need to do. Okay, so, and then we've got 1 more minute before our lesson finishes. I just want to share with you guys this Friday, we will have a math study class. You will get all the information on a WhatsApp message. And this is if you struggle with studying maths and you just need some tips and tools, be sure to hop on at 5 this Friday, 29th of October. Okay. And then I think that would be all from my side. Before I say goodbye, is there any questions or any comments?
Thanks, guys. It was really great today.
Thank you. When are we having the next class? Is it only going to be on Wednesday and Friday?
It's on Monday and Wednesday.
Oh, okay.
So Monday and Wednesday, but this Monday I think is voting day. So next Wednesday, yeah.